Hi and welcome back to Gaffy's Grinds for Leaving Cert Chemistry. This is video 14 in our organic chemistry series. A quick reminder that this is a great place to learn about organic chemistry, but it's important that you watch the videos in the order that they are in the playlist, okay? Because otherwise you're going to miss out on important stuff, and this stuff is just not going to make as much sense. So it's important that you go back and watch those other videos first. Quick reminder, some tips for using these videos is try and eliminate all distractions because they overload your working memory and they prevent you from learning the stuff we're trying to concentrate on. So put your phone in a different room or turn it off. Close any tabs you have open on your computer except this one, and just so you don't get any notifications or any easy temptations to go and watch something else on YouTube. Give this your full focus. That'll ensure that you learn lots while you're watching it. The main thing is I'm going to give you questions to do, tasks to do. And when I do give you those tasks to do, it's really important that you do them. Otherwise, again, you're not going to learn, maybe not even learn anything if you don't do the practice, okay? Practice is the key. Practicing retrieval, practicing remembering things is the key to learning, okay? So that's why the questions are in the video, so really important. Right, today's video is going to be about alkenes, okay? So a quick reminder then about what we've already learned about a homologous series. I'm going to draw a molecule here. This molecule belongs to a homologous series, which we've studied in detail already. Homologous series is basically a group of chemicals that have the same functional group, that have similar chemical properties, that react in the same ways, that have the same method of preparation. But the key thing is that they have the same functional group. The functional group of this particular homologous series is that they all have single bonds. So carbon to carbon single bond. So here this is just a single line, which means a single covalent bond. Okay, so this belongs to the homologous series alkanes. Alkanes. This is an alkane. I'm going to draw another molecule which is quite similar. It's similar because it's got two carbons as well. So this one on the left had two carbons and this one on the right has two carbons. So it's similar in that it's got two carbons. It's similar also in that it's only got carbons and hydrogens. So it is also a hydrocarbon. But this is not an alkane. Why is it not an alkane? Well, first of all, it's got this in the middle. Sorry, I'm going to do that as a circle. It's got this in the middle. A carbon-carbon double bond. This is a different functional group. A functional group is a group, a molecule or a group of molecules that give a functional group is an atom or group of atoms that give a molecule its properties. So its properties in terms of how it reacts and its physical properties, like its melting and boiling point. We call this a functional group. And this is obviously something that the alkane does not have. So any molecule that has got one of these, a C single bond C, belongs to a different homologous series. So if it's not an alkane, we call it an alkene. So E-N-E, alkene instead of alkane. So any molecule that's got one of these C single bond Cs, we call an alkene. Now, just going to clarify that over here. Sorry. C double bond C, like this, is the functional group. And we say that it is unsaturated. Now, in terms of saturation, let's look over here at the first molecule. I'm putting a circle around this carbon. And I can put a circle around this other carbon as well. Either one of those, if I choose to look at just one of them on their own, you will see that each of those carbons is attached single bonded to 4 separate atoms. Okay. Now, carbon can only form 4 bonds. It's in group 4. And if you think back to bonding, we talked about valence electrons. And this is the number of bonds that can be formed by an atom. So if carbon is in group 4, it's got 4 electrons in its valence shell, it can make 4 bonds. So because these have 4 separate bonds to different atoms, we cannot join any other atoms on them. We say that the carbons are saturated. They are already attached to 4 different carbons. In this case, we've got a double bond. Each carbon here is only attached. So I'm looking over here, okay? Each carbon is only attached to 3 different atoms. So look carefully and spot the difference. Now, because it's only attached to 3, we have the potential to break the double bond and attach more atoms to those carbons. And where that is a case, where you can do that, we say that the molecule is unsaturated. It's not saturated with atoms. We could add all more on. So unsaturated basically just means that not all C single bonds, C single bonds. It just means you've got a C double bond C. They're not all single bonds. They're not all carbon-carbon single bonds. If they were all carbon-carbon single bonds, like the alkane over here, we can't add on any more atoms. Okay, now, the C double bond C, because it can be broken quite easily and add new atoms in, we say these molecules will be reactive. They are more reactive than the alkanes. Because the alkanes already have 4 atoms attached, the C single bond, the C double bond C is more reactive than an alkane. That means alkenes are more reactive than alkanes. Okay, so an alkane is, sorry, not there. We say that this particular carbon here, we say that it is saturated. What does this mean? Saturated means it's already bonded to 4 atoms. This means there's no more room for more atoms. We say it is saturated. This one over here, we say is unsaturated because of the double bond. Okay, so alkenes are unsaturated and their functional group is C double bond C. Now, I just want to point out a couple of things here now. The actual shapes of the carbons are going to be different in an alkane than in an alkene. This is the molecule on the left of the screen, the alkane. This is the molecule, the alkene. We've got 2 carbons, and each carbon is attached to 3 hydrogens shown in white. So the carbons here are black. They are attached by a single bond in the middle, and each carbon then has 3 other hydrogens attached. So each carbon altogether has 4. So I'm just going to see if I can make this a bit bigger for a second. Okay, so each carbon has 4 atoms attached, 4 separate atoms. I hope that you can see that. Now, if you think back to your chapter on bonding, a carbon surrounded by 4 separate atoms had a specific name in terms of its geometry, its shape. We say that these atoms, if they're bonded to 4 separate atoms, so a central atom, the central carbon, bonded to 1, 2, 3, 4 atoms, we call this, so I'm going to highlight that over here. I'm going to highlight it using a blue square. So this carbon and this carbon are both attached to 4 different atoms. We say that carbons attached to 4 different atoms have a tetrahedral geometry. Tetra means 4. That's where the word comes from. Hedral means kind of point. So tetrahedral, 4-point geometry. So each atom is attached to 4 separate atoms. Now, if I was to try and hold this up, this can never be flat on a page. So if my hand is a flat page, again, I'm going to try and make the screen a bit bigger. Sorry. Sorry about this now. Okay, so again, I'm just going to hold it here you can see it's a 3D shape. It's not going to lie flat on my hand because it's got these sticking up. The carbons have got hydrogens going in different directions. It's not going to lie flat. Now, what about the C single bond C? So I'm just going to pull this screen down for a second till we get a look at what that looks like. Where we've got the C double bond C, sorry, C double bond C. I am going to show this in a green square. So this carbon and this carbon are carbons that are attached to 3 different atoms. They're only attached to 3. They've got a double bond between them. This is what this molecule looks like, okay? It's got carbons, and say if we just look at this carbon for a second, this carbon is bonded to this carbon atom by a double bond, shown by the 2 bonds here, and it's also attached to 2 separate hydrogens. Now look at the difference. Here, this can lie flat on one plane, can lie flat on my hand. So we say it's essentially only kind of 2D, it can lie flat. Now, because of this, a carbon which is attached to 3 atoms only, we say that this is a planar geometry. Planar because it lies flat on one plane. If I hold it flat like this, there's nothing sticking up in other directions. I'll try and show the other one beside it. Okay, there's nothing sticking up. This one will never lie flat. This one would lie flat if I lay it on the table. This one will not. Okay, so in green now, I'm just going to move this box again, make it a bit smaller. Sorry for a second. Ooh. Up here and make this smaller. Okay, so in green, we call these planar geometry. Sorry, planar geometry. Okay, so the big thing so far, let's quickly recap. Alkenes have a functional group C double bond C. That's a really important thing to remember. That's how you will identify if something is an alkene, if it's got a C double bond C. C double bond C means that the molecule is unsaturated, which means that there's not all C single bonds, CC single bonds, so not all carbon-carbon single bonds. It means there's a double bond present. What does unsaturated mean? It means that you can add more atoms to it, essentially. Okay, if something is saturated, you cannot add any more atoms. That makes these molecules reactive because you could break the double bond and add new atoms in. So we say the C double bond C is a reactive functional group. Any carbon which is surrounded by 4 atoms is a tetrahedral geometry. Tetrahedral geometry. And any carbon surrounded by only 3 atoms has a planar geometry. Okay, so you guys have some questions to practice now. So here they are. So you've got questions 1 to 10. I want you to pause the video now, and from memory, I want you to try and do those questions. So pause the video now. Now you should only be watching the video if you have tried your best to do full answers to those questions. So I want full sentence answers. Check that you've done that. If you haven't, pause it again and write full sentences, because it means your answers are much higher quality. Again, so you should be watching the video if you have done those questions and you've written the answers in full sentences. If you weren't sure of the answers, you can pause the video now and go back and recheck. Go back and look at them again and find the answers. Okay, so the answers are coming up here now. Okay, so maybe make sure you're not looking at the answers unless you've tried the question. So here are the answers. Okay, so the first question, which of the molecules is an alkene? That would be B. Okay, how do you know? I think was the second one. Yeah, how do you know? Well, molecule B is an alkene because it's a hydrocarbon with a double carbon-carbon bond. So it's a hydrocarbon with a double carbon-carbon bond. It's got the functional group of an alkene. It then said, for part 3, draw the molecule B and place a circle in red around the tetrahedral carbon in molecule B. So the tetrahedral carbon should be the one on the left side here, with attached to 4 atoms. It then said in question 4, draw a square in red around the planar carbon in molecule B, around a planar carbon. Now there are 2 planar carbons. They are both the carbons that are attached to the double bond. So both the ones with a red square here are planar. They're attached to only 3 atoms, sorry. Then it said which molecule is saturated, which of the molecules is saturated. That would be A. Well done if you got that right. And then explain, how do you know? Well, it is saturated because it contains only carbons that have 4 single bonds. So there's no double bond, only carbons with single bonds. That's why A is saturated. Which molecule is unsaturated? That would be molecule B. And why? How do you know? Well, it's unsaturated because it contains some carbons that have a double carbon-carbon bond. Question 9, what is a functional group? A functional group is an atom or group of atoms that give a molecule its chemical and physical properties. We learned this earlier, so this was a retrieval question. Well done if you got that right. If not, fix it now. Make sure we try and get that in our memories, guys. It's an important question. It comes up all the time. And what is the functional group of the alkenes? So the functional group of the alkenes is a carbon-carbon double bond, written like this: C double line or parallel lines, C double bond C. Okay. Okay, guys, we're now going to look at our system for naming alkenes. Okay, so say you were asked to name the following hydrocarbon and you were given a drawing of the molecule. So I'm going to draw the molecule first and then we're going to try and practice naming it. So we've got C, 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 and C. We've got the rest surrounded by hydrogens then. So now this shouldn't be starting from absolute scratch because you guys should have already watched a video on how to name the alkanes. And a lot of the stuff that you learn there is going to be relevant here. So step 1 in naming an alkene, step 1 is going to be, and again guys, please just watch while I'm doing this, and if you need to pause and take it down, do that afterwards, okay? Watch while I'm doing it, because when you try and listen and write at the same time, you overload your working memory and you learn nothing, okay? So listen, stop writing if you're writing, listen, and you can write it down afterwards. So step 1 is identify the longest continuous carbon chain that contains the double bond, C, double bond. Now that's the same rule as an alkane, except for an alkane, it was identify the longest continuous carbon chain. It wasn't specific that it had to be the carbon chain that contains the double bond, okay? But in this case, because the double bond is an important part of the molecule, we must include this in our longest chain. And we say that this is the parent molecule. And again, that there shouldn't be a new term for us. We've used that term before. Okay, so with a highlighter now, I'm going to identify the longest continuous carbon chain. Here it is. It's got 1, 2, 3, 4, 5, 6 carbons in it. Okay. So I say it's a 6 carbon chain. Therefore, it's going to get hex as a prefix. It's going to be hex because it's got 6 carbons. It's an unsaturated compound with a C double bond C. That means we're going to call it ene. It's going to get the suffix, the suffix, ene. So hexene, parent molecule is hexene. Is hexene. Okay. That's step 1 done. We've identified the parent molecule is hexene. Step 2. Okay, step 2. Number the carbons from the side closest to the double bond. Okay, so let's go up and do that up here. I'm going to do that with a green pen. So the double bond is here. So the side closest to that, I'm going to start on this side. 1, 2, 3, 4, 5, 6. Now, if you do this the way it is in blue here, 1, 2, 3, 4, 5, 6, then that is wrong. We do not want to do it the way it's done in blue. We want to do it the way it's done in red. Start with the side closest to the double bond. Okay. Now, at this point then, we're going to put the position of the C double bond C into the name. So, looking up here, the carbon begins on carbon 2. The carbon-carbon double bond begins at carbon 2. Okay, so the C double bond C begins on carbon 2. Therefore, we're going to call this hex 2-ene. And as usual, numbers and words are separated by a dash. That's also familiar to us from naming alkane. So hex 2-ene. Step 3, and it might be necessary, it might not be necessary, depends on the actual separate molecules. Indicate the position and type of branches. So if there are any branches, there are not any branches in this molecule, but if there were, then we would indicate their position. Okay, so I've done quite a difficult one there. Okay, I have done quite a difficult one. Yeah, I've done quite a difficult one. So I'm going to get you guys to name me some compounds now, okay? So what about this one? I want you to do this one, please. C. Okay, so you pause the video and name that one now, please. Okay, so you should only be watching the video if you have paused it and you have done or named this compound. Okay, what you may have gone for is, well, the parent molecule. Let's follow the steps. It says identify the longest continuous carbon chain. Well, the longest continuous carbon chain is 2 carbons long. Okay, it's an unsaturated molecule and it's got a double bond. So it's going to be something ene, E-N-E, it's an alkene, and it's got 2 carbons. So 2 carbons is ethene. We then had to number the carbon starting from the side closest to the double bond. Well, as you can see here, it doesn't matter which side you number from. It doesn't matter whether you start from this side, 1, 2, or this side, 1, 2. It's the same thing. Okay. The double bond will be after carbon number 1. So because it's after carbon number 1, we identify, or we stick the position of the C double bond C into the name. Technically, you might have written eth1-ene. But as we know, when things are ones in math or science, we generally can drop them. So this molecule is just called ethene. Okay, right. I'm going to give you another one to do. Well done if you got that right. If not, hopefully that helped clear something up for you. We're going to try this one for me. Okay, so try naming this one for me. Pause the video and do that now. Okay, so I'm hoping that you identified the parent molecule. Longest carbon chain was that 3 carbon chain. And it's an unsaturated molecule, which means that it's got a double bond, which means it's going to be something ene. It's an alkene, and it's got 3 carbons, so prop. Propene is the parent molecule, propene. Now, we're going to start from the side that gives the chain. Start with the side closest to the double bond, sorry. So this is 1, 2, 3. We're going to start from this side. So this just gives us, again, prop 1 ene. Now, because it's prop 1 ene, it's after carbon number 1, this generally just gets written as prop ene. You can drop the 1. Okay, what about this one? Okay, so I'll have a go at naming this one. Pause the video. When I have the hydrogens drawn here, you can pause the video and try naming that one. Right, pause the video now, do that one. Okay, so you should only be watching if you've tried to number these, you've tried to come up with the name. Okay, so parent molecule, we've got 4 carbons in a chain. So it's going to be, and it's got a double bond, so it's going to be something ene, and it's got 4 carbons, so it's going to be butene is the parent molecule, butene. Now let's number the carbons, starting from the side with the smallest numbers. 1, 1, 2, 3, 4. What if I go the other way? 1, 2, 3, 4. So it doesn't matter which way I number, the double bond starts on carbon number 2. That's fine. Doesn't matter which side you go for. I hope that you can see that. Okay, so now our position of our double bond is not on carbon number 1. So we need to clarify where it actually is. But-2-ene. So this molecule we call but-2-ene. Okay. All right. Now that we've done that and we've practiced some, I've got some more questions for you guys to practice now. Okay, so okay, so what I want you guys to do now is I want you to pause the video and do questions 1 to 4. So pause the video and do questions 1 to 4. Okay, so you should only be watching the video if you've done questions 1 to 4. And now do questions 5 to 8, and then we'll go through the answers. Okay, so you should only be watching the video if you've done questions 1 to 8 now. I realize that maybe number 4 might have been difficult there, but I'm hoping that from watching the previous videos on the different length hydrocarbons, when we were doing fractional distillation, you should be able to answer about intermolecular forces that are present between these types of molecules. Okay, so let's go and have a look at the answers now. For question 1, it said draw a molecule of butane next to a molecule of butene. Okay, right, so first of all, I'm going to have to draw that up here for you. Okay, so this is butane, 1, 2, 3, 4 carbons, all single bonds, all hydrogens on the single bonds. And this is butene, C, double bond, C, 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 still got 4 carbons. This carbon can only fit 2 more hydrogens. This carbon can only fit 1 more hydrogen because it's got 1, 2, 3 bonds already. This carbon can fit 2 more, and this carbon can fit 3 more. Okay, so all of those at the ends of those bonds are hydrogens. Right, so it said, in terms of atoms, how are the two molecules similar? So the answer to that is they're similar because they contain hydrogen and carbon atoms only. They don't contain anything else, only hydrogen and carbon. That's what makes them similar. In terms of the number of atoms, how are the molecules similar? Well, they're similar because they both contain 4 carbons. Now, maybe I should just draw in the hydrogens so it's clear, and when you're counting them, I'm going to draw them in here. And you should always draw them in the exam. I'm just being lazy here. Okay, in terms of the number of atoms, in terms of, do you know what? I think you can pause that and correct them yourself. Sorry, pause it and correct them yourself. I think question 1 is pretty straightforward there. I'm hoping. Okay, question 2. You had the general formula. Alkenes have a general formula, CnH2n. So hopefully you recognize that that's different from the general formula for an alkane, which is CnH2n plus 2. So if a molecule has 4 carbons, it will have 2 times 4 hydrogens. How many hydrogens in total are in the first 4 alkenes in total? So you have to add them all together, and you should get 24. Okay, if you're not sure how you got that, well, this is how I would have done it. So in the first alkene, there is no alkene with 1 carbon. That is because there cannot be a C double bond C between only 1 carbon. It's not got a second carbon to double bond to. So there's no alkene with only 1 carbon. So the first 4 alkenes are the ones with 2 carbons, 3 carbons, 4 carbons, and 5 carbons. They're the first 4 alkenes. So to get the total number of hydrogens, we have to, for the 2 carbon alkene, it would be 2 times 2 is 4 hydrogens. So you're going to get 4 plus, for the 3 carbon alkenes, is 2 times 3 is 6 hydrogens. For the 4 carbon alkene, is 2 times 4 is 8 hydrogens. And for the 5 carbon alkene, is 2 times 5 is 10. So add them all. Oh, have I made a mistake? I think I haven't made a mistake on my answer. So just as well I checked. I think the answer here should be 28. Sorry, that's my fault. I think I'm just going to double check that. The 2 carbon alkene is going to be 4. The 3 carbon alkene is going to be 6. The 4 carbon alkene is going to be 8. And the 5 carbon alkene is going to be 10. Yeah. So 10 and 8 is 18. 24, 28 you should get altogether. Apologies, there's a mistake in that answer. How many hydrogens are in the alkene with 8 carbons? That is going to be 2 times 8, 16. How many hydrogens are in an alkene with 14 carbons? Well, it's 2 times 14 is going to be 28. And the next one has a little tricky. How many carbons are in an alkene with 62 hydrogens? Well, we've got to work backwards here. So if we've got 62 hydrogens, it's going to be half that amount of carbons. So 31 carbons. So they flipped the question there. Got to be careful. Explain why an alkene cannot have an odd number of hydrogen atoms. Well, an alkene can never have an odd number of hydrogen atoms because it's always double the number of carbons. And whenever you double a number, the answer is always even. Interesting fact, that. And how many more carbons does alkene with 84 hydrogens have than an alkane with 32 hydrogens? So an alkene with 84 hydrogens has half that amount of hydrogen, so 42. An alkane with 32 hydrogens has, you've got to take 2 away because it's member 2n plus 2. So that gives you 30 hydrogens, and half that is 15 carbons. So 15 carbons. So if 42 carbons, take away 15, that means it's got 27 more. Right? That was quite tricky. So well done if you managed to work that out. Question 3, why would you expect both alkenes and cycloalkenes to have similar reactions? So cycloalkenes are alkenes that are cyclic, or ring compounds. Well, they're both going to contain a carbon-carbon double bond, the same functional group, because they're alkenes. Intermolecular forces are forces that hold together the molecules of substance. Which intermolecular forces are present in an alkenes? Well, all hydrocarbons contain the weakest type of intermolecular force called a van der Waals force. Okay, van der Waals forces between all of these hydrocarbons. Okay. Question 5, propene and butene are both gases at room temperature, but pentane is a liquid. Okay, pentane is a liquid. So, sorry, that should say pentene is a liquid. Pentene is a liquid. Now, explain the difference in state in terms of intermolecular forces. Well, earlier on when we were doing fractional distillation, we learned that the bigger the molecule gets, the stronger the intermolecular forces get. There's more interactions when there's more atoms. So when the chain gets longer, and I keep making this chain, keep adding more carbons and hydrogens, we're introducing more intermolecular forces between those extra atoms. More intermolecular forces means that the particles or the molecules are held together tighter, and they need more energy to overcome these intermolecular forces. So more atoms, more intermolecular forces, and higher boiling points. Define an isomer. An isomer is isomers are molecules with the same molecular formula but different structural formula. And you then had to draw the skeletal formula and name the two different isomers of pentene. So well done if you got this right, guys. This is it here, the answer to question 17. In the first example here, we have a 5-carbon chain. That's why it's called pent. 5 carbons. And it's pent-1-ene. The carbon, or the double bond, is after carbon number 1. 1, 2, 3, 4, 5. Well done if you got that correct. Pent-1-ene. Now, generally, we would just call this pentene. We would drop the 1. But this one over here, again, it has 5 carbons in the chain, 5 carbons in the longest chain, and the double bond is after carbon number 2. 1, 2, 3, 4, 5. So it starts on carbon number 2. So because this is not a 1, we have to include the number pent-2-ene. And technically, these are the same molecular formula. They both contain 5 carbons, C5, and 10 hydrogens, C5H10. This one is also C5H10. Same molecular formula, but a different structural formula. The double bond is in a different place. You then had some sentence starters, so you had to complete the sentences. There's a couple of correct answers here. So long as you have a sentence that makes sense, then it's correct. But here are some sample ones that I've done up. So ethene is an unsaturated molecule because, well, it's because it contains a carbon-carbon double bond. That's what makes it unsaturated. Next one, ethene is an unsaturated molecule, but ethane is unsaturated. Oh, sorry, that's wrong. Ethane is saturated. Sorry. And finally, ethene is an unsaturated molecule. Therefore, and the way I finished that is I've said it has different properties to an alkane. So it's got a different functional group, so it has different properties to an alkane. All right, guys, that's going to finish us up on the alkenes. You should now know how to name an alkene from its structure. And we've also, in those questions, worked backwards to drawing an alkene from its name, and drawing an alkene and naming it, and looking at some structural isomers. One last thing, actually, just before I go, just want to double check that if I give you a name that you could draw a molecule. So we're just going to, one last little question here. What if I said to you, draw me this molecule, pent, sorry, no, we'll go but-2-ene. Try and draw that from the name. Okay, how would we go about doing that? Pause the video and try it. Have a go at that now, please. Okay, right. So how would we do it? Well, we'd start by drawing a 4-carbon chain because it's bute. Bute means 4. Ene means alkene. So I'm going to have a double bond. Alkene means C, double bond C. The 2 tells me where this is. Where is the C double bond C? It's after carbon number 2. Well, if I number these, 1, 2, 3, 4, then the C double bond is after carbon number 2. And then I finish drawing the hydrogens. Now make sure you check your hydrogens. Check that each carbon has only 4 bonds. Okay, now I'm just going to have to, I'm just going to have to move this down. Give me 1 second. Just going to see, hopefully this will move down for me. Yep, lovely. Now just check your hydrogens, be careful. This carbon has 1, 2, 3 hydrogens and it's got that bond. Check it's got 4 bonds, yeah. This carbon has 1 bond on the left. It's got 2 bonds on the right. That means we can put 1 more hydrogen on, okay? If you had another hydrogen here, this would be wrong because it would now have 5 bonds. So we need to only make sure we've got 4 bonds. This carbon is going to be the same. It's got 1 bond on the right. It's got 2 bonds on its left. So it's going to need 1 more hydrogen. And this one on the end is a tetrahedral hydrogen, or tetrahedral carbon. It's got 4 separate bonds. Okay, well done. If you can do that, guys, you can do anything to do with the alkenes. And I'll see you in the next video.